Welcome back. This is section 1.2.2. How can I investigate a function? So what we're going to be talking about is we're going to be graphing using a table of values, and you can check these using your graphing calculators as well. Now, first thing says, are there any values we can't use for x? And if we look, here we have f of x equals 1 over the quantity of x minus 5. Now, if we were to put a 5 in there, 5 minus 5 equals 0, and 1 divided by 0 is undefined, so x cannot equal 5. That's a value we cannot use. So what I'm going to do is I'm going to start making a table of values. So I'm going to pick some numbers, let's say like a negative 5, for example, skip a few, a negative 3, a 0, 1, 4, 6, 7, 10. I just picked some values randomly. If you type this into your calculator, you can look at the table and it's going to make things a lot easier. That's kind of what I did. So here's the values that I got when I typed these in. Negative 0.1, negative 0.125, negative 0.2, negative 0.25. For 4, you get negative 1. For 6, you get positive 1. 7 is 0.5. 10 is 0.2. So looking at these values, we're on negative 3, we're at negative 0.125. When we're at 0, we're at negative 0.2. When we're at 1, we're at negative 0.25. And now, when we go to 4, we're at negative 1. And now when we get to 6, we're at positive 1. When we're at 7, we're at 0.5. 10, we're at 0.2. So if you were to look at the graph on your calculators, you can see what's happening here is nothing is occurring here when x equals 5. We call this an asymptote. And an asymptote is a line that we get close to but never touch or intersect. So not only do we have an asymptote there at x equals 5, but also we'll never get an output of 0. If you look at your table, you never get to an output of 0. So we have another asymptote, a horizontal one, at y equals 0. So the graph is going to look like this. Notice how it should never cross that asymptote. That's our graph. And we call this type of graph a hyperbola. A hyperbola. So now we can answer some questions about our domain, range, and intercepts. So now, our domain. We can use any real number we want to as long as x does not equal 5. That's the only number we can't use for our domain. Our range. We get any output except for 0. So our range is all real numbers as long as y does not equal 0. That's the only output we'll never get. Our x-intercept. Now our x-intercept, if we try to find this algebraically, remember x-intercept is when y equals 0. So 0 equals 1 over x minus 5. We can put 0 over 1. And when we cross multiply, 0 times x minus 5 is 0. 1 times 1 equals 1. 0 equals 1 is not a true statement, and there's no variables. So it doesn't exist. So for our x-intercept, there's none. We solve it algebraically, and also if you look at the graph, we never cross that x-axis. For our y-intercept, we can also find that algebraically. So that's when x is 0. So y equals 1 over 0 minus 5. So y equals 1 over negative 5. Y equals negative 1/5, which we also saw right here. Now negative 1/5 is the same as negative 0.2. Or you could also write it as 0, negative 1/5. They're equivalent, they're the same thing. We have a vertical asymptote at x equals 5, and a horizontal asymptote at y equals 0. Let's go to another problem. Problem number 2, f of x equals 1 over x plus 3. Same thing. We can see, set the denominator, x plus 3 equals 0. So x equals negative 3. That's the value we cannot use. X cannot equal negative 3 because it will cause division by 0. We're going to type this into our calculators to make things a little bit easier. And then we're going to look at our table of values. So negative 5, negative 4. We're going to skip negative 3. We're at negative 2, negative 1, 1, and I'll skip all the way down to 5 just to see a little bit more over there. So when x is negative 5, we get negative 0.5. Negative 4, you get negative 1. Negative 2, 1. Negative 1, you get 0.5. 1, you get 0.25. And 5, you get 0.125. You can see how little of a difference it makes. So we plot these on the coordinate plane. We're at negative 5, negative 0.5. Negative 4, negative 1. Negative 2, we're at positive 1. Then we're at negative 1, negative 0.5. And then we're at 5.125. So what happens here is since x cannot equal negative 3, that's where our vertical asymptote is. Nothing is going to happen there at that line. And we have a horizontal asymptote at y equals 0. So our graph looks like this on that side, and on this side it looks like this. Once again, that graph is called a hyperbola. And now we can talk about our domain, range, intercepts, and so forth. So our domain, we can have any real number input as long as x is not equal to negative 3. Our range, all real numbers we would get as an output except y will never equal 0. Y does not equal 0. Our x-intercept, you can see we never cross the x-axis, so there is none. And our y-intercept. We're going to find that y-intercept algebraically. So that's when x equals 0. So y equals 1 over 0 plus 3. So y equals 1/3. So our y-intercept is at 0 and 1/3. Our vertical asymptote is at x equals negative 3, and our horizontal asymptote is at y equals 0. And let's go to the next page. F of x equals 1 over x minus 4. So set x minus 4 equal to 0. X equals 4. That's the only value we cannot use. X cannot equal 4. So once again, type this into the calculator and you can pull up the table of values. So negative 4, 0, 2, 3, 5, 6, and 8. Just picking some values around 4. So when x is negative 4, you get negative 0.125. When x is 0, you get negative 0.25. X is 2, you get negative 0.5. negative 1. When x is 5, 1. X is 6, you get 0.5 and 0.25. So we're at negative 4, negative 0.125, negative 0.25, negative 0.5. Try that again. So when x is negative 4, at negative 0.125. When x is 0, you're at negative 0.25. When x is 2, you're at negative 0.5. When x is 3, you're at negative 1. Now when x is 5, you're at 1. When x is 6, you're at 0.5. And when x is 8, you're at 0.25. Once again, since x could not equal 4, that's where our vertical asymptote is. X equals 4. And our horizontal asymptote is still at y equals 0. So on this side of the graph, we have this. And on this side, the graph looks like this. Once again, that's called a hyperbola. So if we look at our domain, our inputs, all real numbers as long as x does not equal 4. Our range, our outputs, all real numbers as long as y does not equal 0. X-intercept, you can see we never cross the x-axis. There is no x-intercept for this. Our y-intercept. Once again, set x equal to 0. Y equals 1 over 0 minus 4. So y equals 1 over negative 4. So y equals negative 1/4. So it's at 0, negative 1/4 for the y-intercept. Our vertical asymptote x equals 4. Horizontal asymptote is at y equals 0. Now, in the next problem, we're going to generalize some of this information based on our previous graphs. So what would the graph of f of x equals 1 over x minus h look like? Now, keep in mind, x cannot equal whatever h is. And the graph is going to be a hyperbola. So just kind of making up a number, it would maybe look like something like this. I'm just putting my vertical asymptote wherever I feel like it, and it would have this shape to it. That's the shape, too far. That's the shape of a hyperbola. Now, the vertical asymptote, if you look at our previous problems, it's wherever that h is. So our vertical asymptote is at x equals whatever h is. For all of these in this form, our horizontal asymptote is at y equals 0. In our domain, we could use any number we wanted to as long as it wasn't h. So it's all real numbers, x is not equal to whatever h is. And our range, all real numbers, y is not equal to 0. We'll see some other variations of these hyperbolas as we go through this year, but this is some generalization based on this equation where it's 1 over the quantity of x minus h. Thank you.